question. 2,2-dimethylpropane is added to chlorine gas to create what? And then it asks the type of reaction as well. So let's talk about this kind of reaction and exactly what it is. You've got a simple alkane in the presence of a dihalogen, so in this case Cl2. Now typically what will happen in these reactions is some source of heat or maybe UV light, something to excite the Cl2 will be used. And the reason for that is this is a radical reaction. So in order to think about this and the products we'll get out of it, we should understand exactly what this reaction does. So I've drawn out the mechanism. I'll go to the second board so you can see that. So as I was mentioning, the excitation will allow the Cl2 to undergo what's called homolysis, the splitting of the bond such that one electron from the bond goes to each atom in that bond. So you end up with two neutral chlorine radicals here. So that neutral chlorine radical, driven by the strength of the hydrogen-chlorine bond in HCl, will abstract a hydrogen. And that will leave behind a radical on this carbon right here. And HCl will be the byproduct. So why doesn't it pull a hydrogen from the central carbon? There is no hydrogen on that central carbon, so the only place it can abstract a hydrogen is one of these terminal metals. Finally, what will happen, the other equivalent of Cl dot that was created will combine with the carbon-centered radical that was created by the hydrogen abstraction, and you will end up with this product here. Now, in this case, it also doesn't matter which methyl group the hydrogen is abstracted from, as they all end up being equivalent. If I were to put it on the top right carbon, I could just take that molecule and flip it over, and it would be exactly the same as the product I've shown here. So that is how you sort of think about these questions. That is the mechanism for these radical halogenations of alkenes. The IUPAC name for this compound would be 1-chloro-2,2-dimethylpropane, so that would be the answer. And then while it's a radical substitution reaction, I think the best answer for the kind of reaction this would be is a substitution reaction, as you are substituting a chlorine for a hydrogen. Hope that helps. Feel free to reach out if you need help with more organic chemistry.